Alright, let's say you have the equation xy plus y cubed equals 1, and you want to find the second derivative at x equals to 0. So you may want to use this to find inflection points and stuff like that because, well, that's what you use the second derivative for. So you might want to start by taking the first derivative. So if you take the derivative with respect to x on both sides, xy so that's taking the derivative of both sides with respect to x. So to evaluate this, we're going to have to use the product rule on this side. So the first term times the derivative of the second. The derivative of y with respect to x is actually just dy over dx. Plus, and then the second times the derivative of the first. Well, that's just dx over dx, or 1. I'll write that out if you want. Dx over dx. Plus, and you can rewrite this actually as the derivative with respect to y of y cubed times the derivative of y with respect to x. And this is because potentially these could actually cancel, so you could get your initial d over dx. But we expand it to make it easier to take the derivative with respect to y. And the derivative of a constant, d1 over dx, is just 0. Alright, so here you're left with x dy over dx plus, and this is just 1, so this is y, plus, and the derivative of y cubed with respect to y is just 3y squared, right? You use the power rule, and then times dy over dx equals to 0. So now you want to solve for dy over dx, so you can move this to this side, right? Subtract y from both sides, and then let's factor out the dy over dx. So we get dy over dx of times x plus 3y squared, and this equals to negative y. So if you want to solve for dy over dx, we're going to have to divide both sides by this quantity. So dy over dx equals negative y over x plus 3y squared. Alright, that's the first derivative, right? Let's box that or underline it. Yeah. No. There. That's the first derivative. Now to find the second derivative, we're going to have to take the derivative with respect to x again. So if you take the derivative with respect to x, d over dx of dy over dx, it's not very nice, is going to be the derivative with respect to x of this entire fraction, x plus 3y squared. Is it looking ugly yet? Do you see the quotient rule? Yes, unfortunately you're going to have to use the quotient rule, which is very messy, but okay, on this side you get d squared y over dx squared, which is your second derivative, right? Just y double prime equals to, and then the quotient rule. So if you remember the quotient rule, it's the bottom, x plus 3y squared, times the derivative of the top, so d over dx of negative y, minus the top, so negative y, times the derivative of the bottom, d over dx of x plus 3y squared. And this is all over the bottom squared. So x plus 3y squared all squared. Oh, that's not looking very nice. Okay, so if we simplify this, I'm just going to write second derivative as y double prime. So this is still going to be x plus 3y squared. Now d negative y over dx is just negative dy over dx, and the reason is you can bring constants to the front, right? So actually I'll just write out the steps if you want them. Okay, d over dy of negative y times dy over dx. Minus negative y, well that's just plus y times the derivative. If you expand this out, dx over dx, that's just going to be 1 plus, and d over dx, which we will expand to d over dy of 3y squared times dy over dx. Right? This is just equivalent to d over dx of 3y squared. And all over the bottom, which is x plus 3y squared all squared. Okay, simplify this further. This is still x plus 3y squared. The derivative of negative y with respect to y is just negative 1. So why don't we just bring a negative to the front? Times dy over dx, dy over dx, plus y, 1 plus, and this chunk over here is just 6y if you use the power rule, and times dy, oh that's not pretty, dy over dx, again all over the denominator, squared, so x plus 3y squared. Okay. Alright. So actually now, it might be useful, you see, here, if you rewrite it like that, oh, that's ugly. Sorry about that. If you rewrite, on the left side you have d squared y over dx squared, which is your second derivative. Now, here you have your first derivative. So how are you going to solve this? Well, you don't want to like bring stuff to one side and do the quadratic. That's weird. So you actually have a relation for your first derivative over here. So why don't we bring this down? Let's copy that. And just substitute this stuff over here. Ooh, substitute this stuff wherever we see dy over dx. So let's try that. Y double prime, which is this thing over here, is equal to negative x plus, actually I feel like I'm going to run out of space. Will I? Yes, let's go down a little bit. Forget this. Let's delete it. Okay. So y double prime is equal to negative x plus 3y squared times dy over dx, which is this stuff in here. And that's just negative y all over x plus 3y squared plus y times 1 plus 6y dy over dx, which is just, again, let's make this bracket a bit bigger, negative y all over x plus 3y squared. Ooh. And this is again all over the stuff on the bottom, which I will just copy and paste. Perfect. It's actually there. Okay. So let's continue to simplify. Well, as long as we can probably cancel out these, right, as long as x does not equal 3y squared. Maybe we'll, yeah, x does not equal negative 3y squared. You never know. So, then we'll write, okay, so this is going to be y double prime equals to negative y, well that's just y, plus y times 1, and this is going to be minus, right, because this minus over here. So minus 6y squared all over x plus 3y squared, and again, this is going to be over x plus 3y squared all squared. Okay, I'm sorry this is so long. So what you can do now, you can factor out a y actually if you want. Might make things a bit easier. Yeah, sure, let's do that. Y double prime equals, if you factor out a y, you're going to be left with 1 plus 1. You don't have to do this step if you don't want. Anyways, 2 minus, actually yeah, I'll just finish it. 6y all, that's over x plus 3y squared. And that's, oh no. See, that's why I've been using the line drawer. X plus 3y squared all squared. Okay. So, now, you see we need a value for x, right? X equals something. And we also need a value for y to calculate the second derivative. Well, from your original function, right, let's copy this down. Copy down the entire question actually, if you want. So, and let's make this a bit bigger. Wow, running out of room. Okay. Perfect. Okay. So if we paste our question, it says x is equal to 0, right? So sure, x is equal to 0. So what does y equal? Well, if x is equal to 0, this term is going to be equal to 0, right? So y cubed equals 1, or y just equals cube root of 1, which is 1. Alright, so we can literally go and plug those values into here. So we'll get your second derivative, y double prime. Oh, it's not. There, y double prime equals to, and y is just, sorry, y is 1. So 1 times 2 minus 6 times 1, which is 6, all over 0 plus 3 times 1. So 0 plus 3 times 1, all over 0 plus 3 times 1, yeah, that's just 3 squared. And what you get here, y double prime equals 1 times 2 minus 6 over 3 is 2, 2 over 2. Wow, we don't even really need to worry about the denominator, do we? Because 2 minus 2 is 0, so this entire thing is just 0. Yes, your second derivative when x equals to 0 is 0. Let's box that in. Alright. Yes, that is the answer to this question. I hope you learned something.